This is another demonstration of how to work with a linear programming question from an Edexcel D1 paper. This is from question 8 of the 2011 May paper. There were actually 2 linear programming questions in this paper, and this one is the last question in the paper, although it's actually very straightforward. What we've got is a firm planning to produce 2 types of radios, type A and B, various bits of information, and then the question is to formulate the situation as a linear programming problem defining the variables. It doesn't ask us to solve the problem, just to write it down. So what I'm going to do is go through it line by line, working out exactly what it is that we've got to do. The first thing, of course, is to define the variables. So we've got 2 types of radio, A and B, and I'm simply going to say let X equal the number of type A radios. And I'm going to let Y equal the number of type B radios. We can then go straight through each of the statements, translating them into mathematical expressions. So the first one is at least 50 type A radios should be produced. So we know that our first constraint is going to be that X has got to be greater than or equal to 50. Nice simple statement there. We don't now need to create the additional statement X must be bigger than 0, which we would usually have when we're doing these sort of problems, because we've stated it's got to be bigger than 50, so that's okay. What we've got next is the number of type A radios should be between 20% and 40% of the total number of radios produced. Now I wouldn't write this as one statement being between 20 and 40, I'd actually create 2 different statements. So what I'm going to do for this one is I'm going to say that X must be greater than, notice it should be between 20, so it should really be above, not equal to, but greater than 20% of the total number of radios produced, which is X plus Y. Now you can leave it like that if you want to, or you can take it a little bit further, so this would give us X is greater than 0.2X plus 0.2Y, which would mean move the 0.2X to the other side. 0.8x is greater than 0.2y. That's not very nice though, so if we, what should we do? Multiply both sides by 5, and that will give us 4x is greater than y, which is a much nicer way of presenting it, but as I say, this original statement would be absolutely fine. So but it's got to be bigger than 20%, we've got to do less than 40% as well, so our next statement would be X must be less than 0.4 multiplied by the total number that we've got. And again, what we can do, multiply this out, take it to the other side, we're going to end up with 0.6x is less than 0.4y, and if we multiply both sides by 5 again, that's going to give 3x is less than 2y. So there's a nicer format, but as I say, this would be acceptable. So whether you want to give that one and that one, or these 2, that's okay. We're told that each type A radio requires 3 switches, type B radio requires 2 switches, and that the firm can only buy 200 switches per week. So if we're looking at the total number of switches, we know that 3 times the number of type A radios plus 2 times the number of type B radios must be less than or equal to 200. And I would leave it exactly like that for that one. The profit on each type A radio is 15, profit on each type B radio is 12, and we want to maximize the weekly profit. So creating the objective function, we've got that we're going to be maximizing profit, and the profit is found by 15 times the number of A plus 12 times the number of Y. That's everything we need there. And the only thing that we're missing is we've talked about the number of x's that we've got. We should also state that y must be greater than or equal to 0 as well, because we do need to make sure that we are stating we've got a positive number of type B radios being produced. But that's it. That's everything that we need to be able to state that problem. It's 7 marks and reasonably quick to do that, as long as you work your way through it, create all the constraints, write them in a suitable format if necessary. It may want you to do that with integer coefficients. Make sure you've got all of them. Get your objective function and think, has everything been included that we would want to include? Something like that, that statement y is greater than or equal to 0 will get you a mark, usually. but it's not explicitly stated in there, so it relies on you thinking about the problem. But other than that, that's how to do that linear programming problem.